Okay, so I'm going to show you guys how to do a neutralization reaction question. So this is different from the titration one that I already made a video about where you're using the dilution formula, because in this case you're going to have to use stoichiometry. So the question is, how many milliliters of 0.126 molar H2SO4 are needed to neutralize 0.200 grams of NaOH? So when I see a question like this, I immediately just like to write out the chemical formula. I don't even really care about what they're asking yet. I just like to write out the formula. So it looks like we have H2SO4, and that's aqueous. I think it's a strong acid, which is always going to dissociate completely, plus NaOH, base, also aqueous, and that's going to yield. Alright, so it's a double replacement reaction. So remember that the Na is going to go with the SO4, so it's going to be NaSO4, but we have to remember that sodium is a +1 element and SO4, sulfate, is 2-, so in order to keep this at 0, like electrically neutral, as all compounds should be, we're going to have 2 sodiums. This is all, I don't remember if this is aqueous or not. I think it's a solid, because sulfates are typically not soluble, but I'm not sure, to be honest. Sorry. Plus HOH. You could write H2O because it is H2O, but I like to write HOH just because I think it's easier to balance it that way. Alright, so now you have to make sure that it's balanced. Again, I'm honestly not sure about that phase, but whatever. So we have 2 H's on the left. We have 1 H on the right, so we're going to put a 2 there. We have 1 SO4, 1 SO4, 1 Na. We have 2 over here, so we're going to put a 2 there. So now we have 2 OHs. 2 OHs. Our equation is balanced. Perfect. This is the molecular equation, by the way. Alright, now we're going to look at the question. So it's asking how many milliliters of H2SO4 are needed to neutralize this many grams of NaOH. Alright, so I know that we're going to have to use the molarity formula because that's the only way that you can find the volume from a molarity. And the molarity formula equals moles solute divided by liters of solution. And so we want to find the liters of solution, which will eventually convert to milliliters. And we have the molarity of H2SO4, but we don't have the moles. We do not have the moles, and we do not have grams of H2SO4 to find the moles. But we have the grams of NaOH. And if you remember, you can use this 0.200 grams of NaOH to determine the moles of H2SO4. So, using dimensional analysis, I set it up like this. This is what you're given. Same units as the given. It's going to be grams NaOH. And what we want to do is first find how many grams are in 1 mole of NaOH. And to do that, you need the periodic table. Okay, sorry. So we're going to find Na 22.989770 plus O 15.9994 plus H 1.00794. So that's going to be 39.99711. Okay, and now we have moles of NaOH, but we need to get moles of H2SO4. And we have this beautiful balanced equation. So we're going to look at the equation. Okay, remember keeping the same units, for every 2 moles of NaOH, what we want goes up here, which is H2SO4, and we see that there's only 1 mole in our equation. So there's 1 mole of H2SO4. 1. So now we're going to do our calculation. So we're just going to do 0.2 times 1 times 1 divided by this 39.99711 times 2. And now we have moles of H2SO4, but that's not what we want for the final answer. What we're trying to find is the milliliters to plug into the molarity formula. So using the molarity formula and what we just calculated, they gave us 0.126 molar H2SO4. If you want to label it, you don't have to. I usually don't, but equals, we just calculated the moles. It's going to be 0.002500181 mole H2SO4 divided by, what we're trying to find is we're trying to find milliliters, but when you're using the molarity formula, it's just use liters. That's the volume that it's going to be in. So now we just have to solve for L. The way that I think about it is to get rid of L, you would multiply by L, so you'd have like an L here, dividing this by 0.126. You can do that however you want, it's just algebra. Okay, so the answer is 0.019842703, but liters of H2SO4. But that's not what the question's asking. It's asking for milliliters. And we know that in 1 liter there are 1,000 milliliters, so just multiply by 1,000. And we have 3 sig figs, so that's going to be 19.8. 19.8 milliliters H2SO4. That is the answer. Hope that helped. I'm trying to go quick, but it's still kind of long. Sorry, it got cut off. But when you multiply this by 1,000, it's 19.8.